Welcome, everybody. Thank you for attending our webinar today about Wi-Fi 6 and how it's transforming industrial connectivity. My name is Max Palumbo. I'm one of your presenters today. I work for NXP, and I'm a part of the product marketing organization in the Edge Processing Business Unit. I'm responsible for Wi-Fi software integration. And presenting with me today is Tafiq Ahmad. He's from iWave. He's one of our gold level partners with NXP, and he's going to be sharing the iWave solution for Wi-Fi 6 based on some of our i.MX 8M processors and how this will help solve the challenges of next generation industrial applications. So Wi-Fi 6 is the next generation standard from the Wi-Fi Alliance. And this is really a divergence from the way that Wi-Fi has been updated in the past with 802.11n, Wi-Fi 4, and 802.11ac, which was Wi-Fi 6. They were really focused on enhancing throughput. And you can even see that reflected in the name of the specification, which was high throughput and very high throughput. With Wi-Fi 6, which is 802.11ax, this is a different approach to the Wi-Fi specification. It's named high efficiency. And while it does, of course, offer increased bandwidth, the main objective of Wi-Fi 6 is to increase the spatial and spectral performance of Wi-Fi in highly dense networks like industrial applications. And so there's several new features that have been introduced to help address some of these problems. Things like BSS coloring that will help with spatially overlapping networks to get better performance from your access point, the network that you're participating in. There's now support for downlink and uplink multi-user MIMO, as well as OFDMA. So each individual packet that's sent over the air per contention interval becomes much more efficient with the number of stations that it can communicate with. And there's also been enhancements to the low power performance of Wi-Fi 6 with target wake time. So this really unlocks an entirely new class of devices that can become Wi-Fi capable. The typical battery powered end device that's extremely low duty cycle data connection benefits quite significantly from target wake time, as dramatically lowers the overall power consumption of the system. So these are the real advantages that are brought by Wi-Fi 6 technology. That's, to summarize, the enhanced spatial efficiency with BSS coloring, the enhanced spectral efficiency with multi-user MIMO and OFDMA, and then the enhanced power consumption with target wake time. These are all highly advantageous additions to the specification that really unlock new opportunities and paradigms for industrial and automotive connectivity. Within NXP, we offer not only wireless connectivity, but also a complete series of compute devices from very low costs, sort of Cortex M0 embedded MCUs, all the way up to extremely high performance, multi-core, multi-gigabit A72 class processors. And across the entire portfolio, the NXP strategy has been to integrate our wireless connectivity devices, so our Wi-Fi transceivers, directly into the software packages that support each of these families. So from our MCU and our crossover products, we're integrating Wi-Fi drivers directly into MCU Espresso. And for our applications processors, like our i.MX 6, 7, 8 families, we're integrating Wi-Fi drivers directly into the i.MX Linux and Android BSPs. And this offers a real advantage because it means that from a go-to-market perspective and a time-to-market perspective, all of the risk of integrating connectivity has been taken on by NXP. So we have done the integration into the software package. We have taken on the challenges of validating the integration, of testing and measuring the performance. And in terms of bug fixes and future-proofing the connectivity, we're also taking on the challenge of providing those updates in the software packages as well. So this offers a real advantage to anybody who's looking for Wi-Fi connectivity with the NXP solution, because we're providing, as a part of our standard enablement for the compute platforms, drivers that have been integrated into the development environment, tested on all of our EVKs and the various host platforms. And we also offer the performance measurements for each of those devices that have been integrated. So all of the risk of integrating wireless connectivity has been taken on by NXP, and we're providing a production-ready solution out of the box for our entire family of processors, from our low-cost MCUs all the way up to our extremely high-performance multi-core, multi-gigabit network processors. Today, what we're going to focus on in this presentation is our i.MX family of MPUs. So our i.MX family of MPUs includes i.MX 6, the 7, and the 8 family of processors. And the NXP approach for this entire family of devices is that everything is software compatible. So when we produce the Linux and the Android BSPs for these devices, the BSP environment that we're delivering, which is based on Yocto Linux with the latest long-term stable kernel, is common code that's shared across all these platforms of devices. And so when we integrate the Wi-Fi drivers for our Wi-Fi 6 devices into the BSP, it means that this code is also reusable across all of the i.MX platforms. So from a connectivity standpoint, any of our i.MX devices, the 6 family, the 7 family, or the 8 family, all of them will support the Wi-Fi devices that we've integrated into the BSP. Drill down a little bit farther. Today, we're talking about the i.MX 8 family in particular. So the i.MX 8 is our latest generation of ARM Cortex-A based applications processors. In particular, with the i.MX 8M family, this family of devices offers our highest level of integration yet from a Linux-based processor standpoint, integrating neural network accelerators, DSP accelerators for audio applications, hardware accelerators for things like graphics, for things like video encode, video decode, and image signal processing, as well as high-performance Core A53 domains. To meet some of the low power requirements of next-gen industrial applications, we've also integrated a Cortex-M domain into these processors. This always-on low power domain enables certain functionality in the system to be executed while the much higher power, higher performance core is asleep. So to meet the power envelope of a lot of these next generation applications where there's some level of always-on functionality, we've also integrated this domain into our latest generation i.MX 8 family. Within the i.MX 8M family, we're really targeting Wi-Fi 6 connectivity as the next major release that we're planning for the BSP. And so the NXP Wi-Fi SoC, the 88W9098, really is our flagship Wi-Fi 6 device. It offers 2x2 antenna configuration with both 2.4 and 5 gigahertz communication. It has 2 fully independent Wi-Fi MAC and PHY paths integrated into the chip, so you can simultaneously transmit and receive on both the 2.4 gigahertz and the 5 gigahertz band. And it's fully compliant with the 802.11ax, or the Wi-Fi 6 specification. And so this device really represents our flagship Wi-Fi connectivity, and we're targeting the i.MX 8M as the main family of processors. That's a good fit for this level of connectivity performance that's being integrated into the BSP. So with that, what I'd like to do next is hand over the presentation to Tawfiq, and he can go over the way that iWave is helping to pull everything together and integrate these solutions into a single package.
Hello, everyone. Good morning, good afternoon, and good evening to everyone joining across the globe. Hope everyone is safe in this pandemic and situation. So thanks, Max, for giving a detailed overview of Wi-Fi 6, the technological advantage, as well as the i.MX family support from NXP. Now, looking at the value proposition of Wi-Fi 6 and the use cases which we are looking at with Wi-Fi 6. So from the industrial IoT perspective, so there has been a growth in the number of devices that are connected within each industry. So it ranges from 30 devices to 50 devices. So there is a need to create an efficient network within the industry or within the factory. So this is where here Wi-Fi 6 seems to be the answer, since traditional networks as well as the cellular networks, there is limited bandwidth and not efficient in terms of performance. And right now, the industrial IoT or the artificial intelligence solutions for the industry 4.0 are transitioning towards the camera-based intelligence or the video-based intelligence. So which is where Wi-Fi 6 will help the sensor nodes with this sort of heavy intelligence or heavy data parsing from the edge to ensure that there's no latency in terms of decision making or predictive maintenance. And the last being in terms of 4K video streaming in industries. So there are some industries where there is constant interaction between machines and robots within the industry. So this makes sure that the video streaming happens in a phased and well performed manner. Now coming to the automotive space, Wi-Fi 6 seems to be answer a lot of key questions. So the first one being in terms of the update of your firmware in your connected car. So customers and OEMs are looking to offload the OTA firmware from the cellular network to your wireless network, which is established in your smart home. So looking to extend the Wi-Fi network to update your ECU in your car. The second is in terms of infotainment which OEMs are looking at. So now a lot of automotive OEMs are looking at user experience and infotainment services to build loyalty and help customers in a better experience while driving. And the third is in terms of the V2X. So there is a lot of data transfer between cars, your roadside infrastructure such as traffic signals or pedestrians. So what they call as the V2V or the V2I. So for these multitude of growing applications in the connected car, say, or the connected mobility, there is a need for a well-established Wi-Fi network with enhanced performance. So which is where Wi-Fi 6 seems to be the revolutionary and evolutionary answer. And as Max mentioned, Wi-Fi 6 offers the data rates necessary, the capacity in terms of scalability of number of devices, and the efficiency to manage the gigabytes of data at the edge. Now looking at the i.MX 8, so as Max mentioned, the i.MX 8 looks to be the highest end processor from NXP with the advanced video, audio processing and the enhanced core. So why i.MX 8 for industrial applications? So the i.MX 8 is integrated with a lot of industrial interfaces. So it comes with two PCIe interfaces and multiple CAN, 3 flex CAN interfaces, as well as a 64-bit LPDDR4, which enhances the Wi-Fi 6 throughput. And built with like multiple, it's with the dual core complex system and with the DSP accelerator, you are assured of a powerful core to power your industrial solution. Now, when you talk about connectivity, the first question that comes to everyone's mind is security. So the i.MX 8 has the integrated security features to make sure that your industrial product is safe, robust, and has a secure software inbuilt. Now, what is the security feature? So with an integrated security controller and the dedicated hardware security module, you are assured of security functions such as a secure boot, which guarantees that no one else is able to upload their firmware onto their device or a different OS, or a secure storage to make sure that their storage is only accessible by the user. The i.MX 8 security controller is built in with functions such as the high assurance boot and the cryptographic accelerator module, what is also known as the CAM. So with these integrated functions, security is taken care of as an end product. Now, the software required to run your solution or your product, the i.MX 8 always boasts on an extensive software ecosystem. So with Linux, Ubuntu, QNX, Android, VxWorks, FreeRTOS, and the list keeps growing. So you can choose your software requirement as per the end application. And the key feature in i.MX 8 is the dual OS support. So you're able to power multiple displays with multiple operating systems and with the integrated graphical processing unit and video processing unit. And this comes the support packages are production ready with continuous upgrades over time to time. So you are assured of a production ready solution from the software packages as well. Now the last point is in terms of the longevity. So anyone looking to install a product in the industry or in a connected car looks at product longevity. So that way NXP and iWave together ensures a product longevity for our system on modules, computers and processors for minimum a period of 15 years, which helps you in continuing the single unit for a long period. Now the processor is available across industrial grades, commercial grades, and automotive grades, as well as the complete end solution, which makes sure that the solution is able to withstand temperatures, vibration according to industrial standards. And looking at the extreme heat that is possible due to the multiple display and the additional interfaces, the i.MX 8 processors it comes complemented along with our thermal solutions such as the heat sinks, the heat spreaders, which makes it as a complete end solution taking care of the thermal characteristics of the solution. Now looking at Wi-Fi 6 enabled platforms. So there has been a recent trend that system on modules is now the preferred product design trend across the industry. It is expected that the system on module market is expected to grow with an annual growth rate of 11% from last 2020 onwards. Now looking at the iWave portfolio system on modules. So we have the complete scalable and modular platforms across the i.MX 8M, the i.MX 8 Quad Max, and also the single board computer. So we have the SMARC 2.0, the SMARC 2.1, and the Q7 2.1 standards. So it is dependent on customer application and requirements that we can help you choose the right module for the right end application. So for example, the SMARC supports 2 gigabit Ethernet interfaces, whereas the Q7 module provides for extended input outputs on the connector, which is more suited for industrial applications. Whereas the SMARC with a small footprint makes it more suitable for multimedia and infotainment applications. And these system on modules are integrated with the corresponding Wi-Fi 6 Jodi W3 chipsets on the module, so which enables you and the end customer to reduce the development time and reduce the complexity on the carrier cards. And for customers not looking to go for a complete carrier card design approach or a chip down approach, we also have the single board computer approach, which has all the additional interfaces, the AOI connectors, and the necessary modules on board to help you get started with your end product development. So with these complete feature-rich system on modules across multiple standards and multiple processors, iWave's mission with these modules is to reduce your development time, reduce your complexity, risk, as well as speed up your development time and make sure that you focus on your key differentiation and competency and leave out the design complexity to iWave. And iWave has helped customers reduce their development time by around 9 months by going for a system or module based approach. So just to give you a brief idea of what is the potential throughput through Wi-Fi 6. So here is a brief demo setup which we ran at a lab setup. So here what you see is the Avatar, the one of the highest grossing films, which is located on the laptop server. So the laptop server transmits this video to the i.MX 8 based Wi-Fi evaluation kit what we have, which acts as a client. So the laptop server and the i.MX client are connected to the Wi-Fi network through the router. And now this video is streamed through the Wi-Fi 6 network, and then the i.MX 8 is connected through HDMI through the 4K display. So with this makes sure that the video streaming and the corresponding devices, the data transfer happens at a really good speed, even when Wi-Fi 6 is supposed to be the best method when there are a lot of devices. So looking at the speed of Wi-Fi 6, As you can see that the bitrate for Wi-Fi 6 which we have achieved from is around 700 to 34 in the range of 690 to 700 megabits per second, whereas traditional Wi-Fi was in the range of 340 to 360 megabits per second. And this only can be observed when you have more number of devices, the performance really is achieved to the next level. So how do you get started with Wi-Fi 6 products? So you must have seen a lot of commercial B2C Wi-Fi 6 routers already available in the market. But how do you get started with a Wi-Fi 6 or your industrial product or your automotive product? So iWave has built an evaluation kit integrated with a Jodi W3 and an M.2 slot and the IO expansion connectors available on the evaluation kit for you to get started with integrating your end application or your end product. This evaluation kit is integrated with an extensive board support package across Linux, Ubuntu, QNX, and Android. So you are assured of a complete production-ready solution from the software and hardware. The BSP is integrated with all the Wi-Fi 6 features. So it can be the Wi-Fi Direct, the Wi-Fi access point, the Wi-Fi client, or it can be the MAC randomization. So all the Wi-Fi 6 features are integrated in the BSP, which enables you to get started with the application in no time. And then with our complementary, the heat sinks, the heat spreader, and the thermal solutions, you are assured of a complete end-to-end solution. Thank you. Thanks for your time over the webinar. We are now open for question and answers.